Hello everybody and welcome to my YouTube channel once again. In this video I will share with you the 7 most common reasons for having flaky tests in Ruby on Rails. But before I talk you about these reasons, let's see what are flaky tests to ensure that we are all on the same page. Okay, we probably all agree that flaky tests are one of the most annoying things when you are a developer. But what are they? Flaky tests are tests that fail in a non-deterministic way. That means that most of the time they passed, but sometimes they fail for no apparent reason. So now that we know what we are talking about, let's go straight into the topic. I will show you the 7 most common reasons for having flaky tests in Ruby on Rails, and I will also show you an alternative in some cases using RSpec. If you are not using RSpec, don't worry, just get the idea of the solution and try to apply it to your front-end work. So without further ado, let's start with the first one. So reason number 1, your test checks for array equality when ordering doesn't matter. This happens, for example, when your code returns an array and your code doesn't ensure any ordering, but the developer that is writing the test is checking for equality. So basically the developer that is writing the test is expecting the collection always to have the same order, but your code doesn't guarantee that. So in some conditions the test will pass, but in other conditions the test might explode. Let's see that with an example. So imagine that you have a blog application that has posts. Posts can have comments. Now you want to fetch the comments of a post in no particular order. The problem with this example is on the expectation. It is checking for equality, but if for some reason the database returns the data in a different order, it will fail. To fix it, you can just use match array, as you can see here. The good thing about using match array is that it will check that all elements from the collection are present, but it doesn't care about ordering. So number 2, Capybara tests that check for an element that sometimes take too long to load. So Capybara or Selenium tests are super useful because you are basically testing your application as your user would use it. The problem with that is when you have some elements in the UI that take too long to load. For example, imagine that you are testing a form and when you submit it, you should expect to have something on the page. But imagine that sometimes that element takes too long to load. In most cases, probably it's going to be there when you have your expectation. But the issue comes when it takes too long to load and you are already running the expectation code there, but the element is not there yet. As you can imagine, fixing this kind of tests isn't an easy thing. In most of the cases, you will have to look at each case in particular. You could look at things like your test configuration to see if everything is okay, or also take a look to your UI to see that everything is correct before running the test. But sometimes it will just take more because of the load that your computer has at that moment. And then for those cases you might want to add some wait time. But the problem with that, with using that solution, is that it will also take longer for your test to run. So as I said before, these aren't what we would consider a low-hanging fruit, so good luck fixing those. Okay, number 3, explicitly setting the ID. I must confess that I am particularly annoyed every time I see one of these, and they are basically setting the ID when you create an element to later compare it. Let's see this with an example. So as you can see here, we are creating 2 posts and explicitly setting the ID. Then we are fetching their most recent posts and comparing those below. The problem of doing this is that setting IDs should be your database's sequences responsibility, not your code's. So if you keep setting IDs in your code, at some point you will have a flaky test because you will be setting an ID that probably your database has already set before. So let's see a much cleaner solution for the previous example we saw before. As you can see right now, we are letting the database do its job and set the ID for us. To make the comparison, what we are doing is just assigning the new posts that we are creating to some variables. And then what we are doing instead of checking the IDs is just checking that those posts that we have in the variable are included or not included in the elements returned by our scope. Number 4. Testing that your database sequences will create a predictable ID. This is a variation of the previous one, but a little bit more subtle. At this point, you are letting your database set the ID, which is great, but you are expecting it to create a specific ID. Let's see that with an example. So as you can see in this example, we are creating a post, and as we said before, we are letting the database do its job and set the ID. Problem here is, as you can see in the expectation, is that we are expecting the DOM-ID function to always produce the same result, which would be basically to say, hey, I'm a post and I am the post number 1. But what if the database hasn't set the number 1 as ID? So as you can imagine, the reality is that you should never expect your database to always have the same ID. Probably most of the cases it will assign number 1 for the post as we expected, but some of the times it might not, and then your test will fail. Let's see a non-flaky alternative for this test. As you can see, the only thing that we are changing this time is the expectation, because the creation of the post was correct. But in the expectation, what we are doing is, instead of expecting a fixed ID, always expecting, for example, the post to be 1, we are concatenating the post ID. So this time, it doesn't matter which ID our post has, we will always have a green test. So after seeing this example, I hope you understood the moral of the story.
Do not have expectations on IDs in your tests.
And with that, let's go to number 5. Time-dependent tests. This is a classic. One of the variations is to have an expectation on a variable that can change its value over time. Let's see this with an example. So in this example here, we are creating a post, and as you can see, we are explicitly setting created at. Then we do something that may take some time, and then we are expecting the post created at to have been created 2 hours ago. The problem in this case is that depending on how long the do something part take, it could be flaky, because depending on how fast the test is executed 2 hours ago at the beginning could mean something different at the end of the test. Other types of time-dependent flakiness can be, for example, tests that depend on a time zone that could fail, for example, depending on the time zone that you are executing the test. And a classic that always strikes back. Tests that always fail on light savings time. These are the typical tests that always fail when you change your clock to adjust that for light saving time. What could you do to solve this kind of test? Well, for the issues with time zones, you just need to ensure that you are always using the same time zone. And for the other tests, you could explore using freeze time and execute all your instructions within a freeze time block so that the clock of the system doesn't change while you're executing them. Okay, number 6. Depending on third parties. Imagine that your code makes a request to a third-party API. Most of the times, that API would be available, but at some point it could not be available, and yes, your test will fail and you will have a flaky test. For fixing that, I recommend you exploring the gem BCR. So BCR introduces the concept of cassettes that you can record once and replay after that. In BCR, you will indicate a file to record the request. The first time you execute the test, the file will be empty. At this point, BCR lets the system perform a real request, and it stores both the request and the response that the third-party system sent back to us. The next time this request is made, BCR will realize that it has a recorded cassette for it, and it will automatically return the recorded response without fetching the third-party API this time. Okay, and lastly, number 7, tests that share a state. This is less common, but it could happen if your tests or your code use global variables that are modified by different tests. Some examples of this could be having global variables, having class variables, using and setting values in Redis that are modified by different tests, and also setting and modifying environment variables. Okay, at this point we have seen the 7 most common reasons for having flaky tests in Ruby, and we have seen many techniques to avoid them. But what do you think is, in my opinion, the best way of not having flaky tests in your code base? Teamwork. Probably you didn't expect me to answer that, but the reality is that the development team must commit to not having flaky tests before the situation goes out of control. Okay, and let me highlight this. If you and your team don't pay attention to flaky tests, at some point you will not be able to release features as you want, or you will have issues releasing a hotfix because when you're running that test suite you have, it will explode. At some point it will be for some flaky test that you have seen some weeks ago, then the typical flaky test that it's been there for months, and so on. At some point it all comes to a situation in which it's impossible to develop new code. So, in my opinion, the best thing a team could do is to address flaky tests as soon as they appear. And that's my recommendation to you. Have zero tolerance policy with flaky tests. Fix them as soon as they appear. And that was it for today's video. If you enjoyed the content, please consider subscribing so that you don't miss any further updates. And if you liked it, please smash the like button. And if you have any questions, please leave me a comment in the comment section down below. And without further ado, hope to see you in my next video. Adiós.